Okay, we are recording. It's all yours.
So I'll just let everybody know about a few events that we have coming up and one announcement. So last week, University of Texas held an event down in Austin for those folks who were not able to attend the Esri User Conference out in San Diego to provide a recap of that and a social networking function. And then next week, we are holding one of those here in the DFW area, and we are partnering with SCOG. So it'll be a recap of the conference for those who didn't attend and a happy hour as well. Pam Kirsch with Esri will be presenting an overview of the latest software enhancements and market trends. The event will begin at 5 p.m. with the content to start around 6 p.m. or so. And it's going to be held at Bar Louie in Las Colinas. So there's more information on that event on our website. I'd also like to announce Geocaching Day. University of Texas is excited to participate in the International Geocaching Day, which is on August 17th. Details are currently being finalized, so keep an eye on the University of Texas announcement emails to go out on that. And then finally, University of Texas is proud to have our corporate sponsorship program back in place. Following our reformation as a 501c3 nonprofit, we have begun accepting corporate sponsorships. We'd like to recognize our UTM level sponsor, New Edge Services, as well as our 3 state claim level sponsors, AECOM, Altera, and Dunaway Associates. Like I said, there's sponsorship from companies like these that allow us to continue to provide services like these educational webinars and our social functions, so thanks to our sponsors. And if you are with a company who's interested in potentially sponsoring University of Texas, please visit our website or send us an email, and the information is up on the screen right now. And that's all I've got, Brian. I'll turn it back over to you.
Okay, perfect. Once again, everybody, if you're just logging in here, go ahead and rename yourself in the Participants tab to first and last name so we can get you the PDHs. I'm going to go ahead and probably get this thing started here. I'm going to go ahead and introduce our speakers today. Really excited about today's presentation, FME for GIS Process Automation. I've been wanting to have this one as a speaker series topic for quite a while, and I think we've got lucky and put together a great presentation with our speakers today. We have Kat Gracie. She works with Safe Software. Has been with them since 2014. She's a recognized expert in the field, and she is we'll be talking about FME here. And we have Roger Comstock. He actually works for Atmos Energy out of the Dallas-Fort Worth Metroplex area, and he is going to be giving us kind of more of a real-time, Kat will do it as well, a real-time demonstration of FME for a specific project. The one thing is the moderate consequence areas, the MCAs. Regulations have changed in the natural gas pipeline industry, and Roger will show us how he used FME to help integrate their data. It's basically what we're talking about is data integration technology. And so FME for GIS processes and automation. First up is going to be Kat Gracie, and we will go ahead and turn this over to you. So we appreciate you all being here today, and looking forward to it.
Thanks, Brian. So thanks everyone for joining us today, and especially thank you to University of Texas for inviting me to speak. I sure appreciate the invitation, and Roger, I appreciate you're going to go and show some really complex, amazing stuff that's used with FME. So I'm definitely doing the simple version of FME, and Roger's going to show you the complex version. So what is this FME thing anyways? Well, it is a data integration platform with the best support for spatial data worldwide. So that's what marketing tells us to say. But really, what is it? Well, it's all about moving your data around. Way back in the 90s, our co-founders decided they were going to make a feature manipulation engine. It's a bit of a mouthful, so I think we all won when that got shortened to FME. So what I've got planned for us today is to talk through some common data challenges, provide you with an overview of who we are at Safe Software, introduce you to FME, our platform, and then just give a short demo, which in theory, I'm going to prove to you that if I can make this work, you could also make this work. And then we're going to close out with some resources. The world's most valuable resource is no longer oil, but data. When we saw this quote published by The Economist in 2017, we immediately saw the truth in this, and it continues to ring true, even truer today. I don't know if anyone saw on Netflix The Great Hack, But that, when they're advertising on Netflix, that's actually one of the quotes they have, is that data is more valuable than oil. And I think because we're in Texas, we could probably make the joke that if you have both oil and data, you're really making money. So organizations spend a lot of money and resources collecting data, but that data is only valuable when it's actually used. Data silos are in place in every organization, usually due to financial restraints by project or the longstanding tradition of dividing departments by function. In reality, each area of specialty should be able to use the best fit for purpose applications, but the data they need to access is often stored in a way that either makes this impossible or makes it extremely difficult to share across teams. And if it is done, it's often done as a custom-built solution, and then that will break in the next update, or updating requirements is extremely costly. And then, you know, the big thing that we always talk about is if you aren't automating this, staff are going to spend precious time performing repetitive administrative tasks with an increased chance of failure. So really, automated integration workflow is critical. Whether you're doing some intense regulatory reporting like Roger is going to show us later, or you're planning for the next hurricane, or you're just making sure you know where your assets are, your data needs to flow freely between applications to get the job done efficiently. By implementing data integration, you're enabling your staff to use the best fit for purpose applications and to focus their efforts on innovation rather than repetitive integration tasks. This is normally where I say, let your big brains do big brain work and let FME just do the repetitive everyday tasks. So we are lucky enough to have come up with some brilliant, if I do say so myself, poll questions, which Brian is going to start now, somehow, magic. And these are there's 2 poll questions that I would love for you guys to answer. If you know about FME, that's the first question. And we'll just let that run for a few minutes. Or not minutes, seconds. Half a minute. I'm just going to start saying numbers now. And now Brian's going to pull up the answers to those questions. So looks like we got a whole bunch of what is FME. That's great. You're at the right place because we are going to talk about that. Some beginners and a few experts in there. Glad to hear that you guys are still showing up to have some fun with us. And the next poll question. So yeah, this is all about managing your priorities. Not a problem all of us have. Actually, it's a problem all of us have. Give it a few more seconds.
Still got a few people answering here, so I'll go ahead and end it here and we'll share it with you.
Okay. Great. Let's see, automating processes. These are people I love. Let's see if we can get you help in that. But the reality is that self-service portals, hiring staff, managing and limiting requests are all important as well. So, but yeah, let's get some automated processes going. Okay, thanks, Brian. So who are these safe software people anyways? So Safe Software was founded 25 years ago by our 2 co-founders, Don Murray and Dale Lutz. They recognized that local companies were encountering a lot of data challenges. This was back in 1993, and they came up with FME and decided to help. At the time, they decided to support 7 data formats. So we have grown over those 25 years, where over 10,000 organizations use this worldwide. If you caught the very beginning of the webinar, you would have heard that we are located just outside of Vancouver, Canada. We have 128 countries that have FME customers. And in order to do that, we actually have a full partner network supporting those customers as well. SAFE doesn't do any services, so if you need help with that, we get our partners to do that. So our key markets, kind of came out of the world where anyone that had assets on the ground and needed to map them or be able to do the whole CAD to GIS problem. About 50% of our customers are government. That's worldwide. But anyone from 1 to 2 person shops all the way up to large multinational organizations use FME. And well, we came out of that idea of, asset management and mapping. Now anyone with data could use FME and does use FME. So I was told everything is better in Texas. So I wanted to give you some examples of some local customers that we have. We do have a requirement. We have to have permission to use your logo. So in order to fill out this slide, I put some less local customers, but I hope they were spatially relevant. And I will say, obviously, not nearly as good as those Texas customers. This is where I need to put the winky face, which I put in my script. So hopefully you guys know that as a joke. So our FME platform enables you to connect data applications using a visual interface. So there's no coding. But if you are the type of person that does want to code, don't worry, we have options for you as well. The ability to connect from different systems, be able to transform the data to meet your needs, and then that big automation, 75% of you wanted to do this, is really important. And that automation frees you and your team from repetitive manual tasks. And we always want that data to be most up to date as possible. So, dun dun dun, another 2 poll questions. Now, I think we were too easy on you guys the first time around, so these questions are harder. They're not harder, I was just joking. So I'm going to guess that there's going to be a huge number of government customers and a huge number of energy customers. That's my wild Texas guess. So we'll see if I'm right. Oh, look at that. Other. So we've missed out a whole group of people who don't fit in our sort of traditional industries. And utilities and telcos, they're making energy work for their market share. And our next question is, what type of data do you use?
For those that selected other, by all means, type it in the message box and let us know what the other is.
Yeah, that'd be fantastic. I wonder if anyone's scratching their head around BIM. I know it's not quite as popular in North America as it is really exploded in Europe, and that's those big building information models, so 3D and building information models. Is that third one? Fourth one, sixth one, whatever number it is. Don't ask me to count. I mean, GIS is the big winner here. I guess it makes sense, mostly because this webinar is called Automation in GIS. Yes, all of the above probably would have been a good option or a multiple selection. Yeah, definitely the GIS. Awesome, thanks guys. Don't worry, there's one more poll opportunity for you guys to share your expertise. So, connecting your data. So the key thing here is your data is not all going to be in GIS. As everyone said, all of the above, multiple selections, all data types. So you don't want to just be working with GIS data. You want to be able to pull that data from wherever you get and make your business decisions with all the information that's available. So FME supports geospatial data, structured and unstructured data, linked data, time series, and more. So you've got all these different sources. And then you can also extend FME with custom connectors through REST or R or Python or other technologies. So if you love your Python, don't you worry, you can actually call those Python scripts from within FME. So the big things were connect, and then one of the things that we have noticed, so I kind of briefly talked about this, when we started back in 1993, it was all about CAD and GIS. But as you guys all proved by saying all of the above, that GIS professionals are not just working with GIS data, they're not just working with CAD data, they're not just working with database data. So there's all these different options available, and over time we have added to our formats that we support to meet those needs of your different projects that you're working on. So a lot of these times we actually get dragged into into different formats as opposed to consciously making a decision. But you know, as you can see, we're moving up into this whole business intelligence, indoor mapping, virtual reality, and then now into machine learning. So wherever you guys are working, we want to make sure that we're there as well. So this is where I say, I make fun of it, is like, oh, data ingredients are fine, but isn't a data pie so much better? Ha ha ha. So isn't it enough that you have the data and that you're able to make it into another data format or make it available for another application? We actually have to be able to make your data, transform your data in a way that makes it actually usable, right? You know, your data formats could end up being in a different schema. You need to make sure the data is correct, so you've got to do validation. You want to make sure values are in range. And there's any other types of data transformation. So in order to be able to effectively use your data, you actually have to transform it. So we provided a library of transformers to allow you to integrate your data. And again, this is about increasing the value of data by making it usable where, when, and how it's needed. And then providing data validation actually allows you to make sure that the data that you are providing has high quality. And the nice thing here is that you can easily expand your workflows to include new data sources as they become available, and then transform that data to fit these different scenarios. So here's that 75% of you who want to automate your workflows. Automation, we all know this, automation saves time and ensures the data arrives on time. So it's always available and it's always up to date. So with Fme, you can create all your automation and transformation workflows based in a GUI, so a user interface. You set up business rules that trigger workflows to run on schedules in response to events, you know, such as an update to a database or an email. You can also automate workflows to send notifications via text, email, or web protocols. So for example, you could set up a data upload service that provides validation and a detailed pass and fail record, which is that pass data, and it can send back a report on all the failed data. So that
Hey, Kat, real fast, a couple people commented that they're having a little trouble hearing you. Not sure if there's anything you do on your end. Just wanted to let you know that if you could try to adjust the mic or something.
Okay, is that a little bit better?
I think so.
Okay.
I'll let you know.
Okay, thanks a lot. Appreciate that. So yeah, everyone knows that you don't want to be doing manual data entry. That's no fun, and it increases the possibility of human added error. So really, again, this comes back to that big brain stuff. Let your big brains do big brain stuff, and let Fme do the manual, repetitive tasks. So just one more slide before we kind of dig in a little bit deeper. We have an integration platform, so we have an Fme desktop product. This is your authoring tool where you build and run workflows. I mentioned this because that's actually what we're going to demo on today. And then we have our Fme Server product, which allows you to do data automation, and that is available either on premise with Fme Server, on the cloud with Fme Cloud. So this is all about flexibility to allow you to use you know, things that work best for your particular scene. Okay, final poll question. Are you planning on starting Area 51? I don't know if anyone noticed, but we do have a little extra guy on this particular slide. That's our Zipster. I think he might be considered an unidentified flying object. And oh, we got some people going. That's awesome. I expect full updates from everyone that does go, and let me know how it went for you. So I had this whole plan. The reason I asked that question is because I had this brilliant plan that I was going to create a workflow to help you with your Area 51 storming needs. But for anyone that's ever watched Pinky and the Brain, my brilliant plan to take over the world lacks execution. So unfortunately, we're not going to help you storm Area 51. I instead am going to show you a simple workspace that's going to be used to determine addresses that are affected by various storm surge levels. So with that, I'm going to flip over to Fme right now. Maybe. Ryan, you can confirm that you can see my Fme desktop now?
I can, yes.
Excellent. Thank you. And you can still hear me?
Yes.
Perfect. Thank you so much. So what I'm showing you guys here is FME desktop, just a blank canvas. And I'm actually going to build a workspace from scratch. I know live demos is very scary. I'm very nervous as well. This is just going to be a really simple one. Roger is going to show you a very complex one and prove some of the amazing things that can be done. But I don't want to overwhelm you quite yet. So what I have is I have an addresses geodatabase. So a geodatabase just contains some addresses here in Vancouver. I also have a coastal surge zone GML file. And the coastal surge zone is basically how high the water will come based on various surge levels. So if I open my data folder, I'm just going to drag and drop the addresses geodatabase on here. Okay. Okay, I just want the addresses. I don't want the boundaries. And now I've added that data. Go back and I'm going to add my boundary, and this is my coastal zones and this GML, throwing that out there. Each zone would be an individual feature, so I'm actually want them to just be a single merged feature, so I'm going to change that. Throw that on there. And bingo, bingo, bongo, I now have my geodatabase and my city GML, my GML there. Because that doesn't really make a lot of sense, I'm just going to quickly add some annotation right there. That makes it super obvious. I can quickly look at this and I can see what attributes are available in that geodatabase, and again, what attributes are available on the GML as well. So this is going to be a pretty straightforward workspace. Basically, I just want to compare the postal address to the coastal zone and figure out what address, what surge zone each address is on. So to do that, I'm going to do a spatial filter right here. Addresses are the candidate, and coastal zones are the filter. Now I could do things like just make this a little bit prettier like this. Or there's the ability to kind of move things up and down. Because this is very visual, people like to be able to keep their workspaces nice and clean. So this is just pretty straightforward, so I'm actually just going to go ahead and run it to that point and take a look at it in our visual preview. So this is good. So we had like 13,000 addresses, with 5 surge zones, and about 4,200 of them are actually in those zones. So if you look here on the bottom of my screen, you can see the different addresses that pass that are in the different zones, and you can see all the data available on it. So I just made those join smaller.
Hey, Kat, there's a little bit of feedback. Just wanted to fill you in real fast.
Okay, thanks very much. My typing is loud, I guess. Apologize, everyone.
Oh, you? But we can see the screen fine.
I'm just going to actually show you these. Oops, that was addresses. I'm going to show you the zones. So as you can see, I can zoom in here. These are just these different surge zones, right? And if anyone has ever been to Vancouver before, this is downtown Vancouver, and this is Stanley Park up there. It looks like a duck's head. It's just a subset of that data. Okay, now that I know, which address is affected by which zone, I actually want to just test, put in a tester, because I want to actually only find some specific zones. Oops. I just thought correctly, though. Let me do this. Okay. So again, I'm only looking here at the past ones. I don't care which ones failed, they're not going to be affected. So just like everything else in life, when you need to test, you have a little GUI here, so you can say, set up your operations. So I'm looking for zones in, and so, for example, I know that their big storm is coming up next week, and the suggested surge zone is going to be 300 feet. So I'm going to say everything that is in the 100 200 and 300 feet zone, I want to only get those addresses. So I'm just doing a test of that. Okay. And hopefully this works perfectly because I had a problem with it yesterday. Bingo. So again, we're looking at past addresses. So there's about 2,000 addresses that would be affected by a 300-foot storm surge. And again, in the interest of keeping things nice and tidy, I'm going to actually just do a little bit of cleanup on the data. And I'm going to add an attribute keeper. There's a whole bunch of attributes in there that didn't really make a lot of sense for what I'm trying to do here. And there's attribute keeper. And I'm just going to come up and I'm just going to say I only want to keep the stuff that's actually related to the address. I think everyone knows that we're on the same country and the zone. Okay. So I'm just going to output these those 5 different attributes. Again, this is all about keeping things clean and tidy. I didn't need that additional information. Now, finally, after all this, I'm going to actually write out this data. And I just decided for ease of use, I'm just going to write it out to Excel. So I have 2 options here. I can write it out to an Excel writer. Type that in. Throw that on there as an Excel and do that. But because I actually want to do something a little bit fancy with this data, I'm actually going to not write it out to Excel. I'm going to write it out to a feature. And I am at fingering this. That's not very good. Feature writer. And I'm going to use my feature writer. I'm going to use my feature writer to actually write to Excel. By doing this, it actually allows me to write to Excel, but then do something beyond that. And I have learned something very important about myself that I apparently cannot type at all. So I'm going to have previously typed this location out just to save myself that error message. Okay. And I'm just going to run all of this now. Now, in theory, I should be able to open it up. And there's my new Excel spreadsheet. And voila, proof, I did actually send it out. And it does only have zones 1, 2, and 300 different addresses. Yay! So the reason I used a feature writer instead of an Excel writer is because now that I have this, I actually want to do something else with it. I'm going to pretend that my data set is much more robust than it actually is, and I'm going to pretend that they actually have email address available to it. So I could now email, right, and send it out to an emailer and set that up. Or perhaps this list is actually a group of people that have signed up for text messages. So I want to instead use Twilio to send these guys all a text message that says, oops, that's not send them a text message that says, hey, you guys are going to be possibly affected by storm surge when this big storm happens. Or, potentially if there's anything else there. You could have it automatically write to Twitter or do any other things. So this is a pretty simple workflow. It's obviously I've done it in like 10 minutes. It's not supposed to be really complex. But what really this ends up happening is you build this workflow, you automate it, you send it up to Fme Server, and everything's going well. And then someone says, you know what? It's not really enough that we tell them that they're going to be affected by this storm surge. We actually want to go ahead and tell them where to go. So, kind of the next step that I would imagine, someone coming to you and saying, like, oh, I actually want you to go ahead and find the community centers that are available in this area. And I want you to, when you send out this email or you send out this letter or you send out this tweet, I want you to tell them where the closest community center is. That's related to outside of the storm surge area, but is the closest one to their particular address. So that's how you start ending up building this different complexity, right? This is where you're going to end up with that logic type workflow that is huge and complex and has a lot of things going on, is by building up these very simple workflows and just adding some. And of course, I didn't want to overwhelm you either. So hopefully that was pretty straightforward, and everyone has got a little idea of how to use FME. Back to my slide deck. I'm actually almost perfect for the time, I think. So just really quickly, wow, this is amazing. I had so much fun. I can't believe Kat was able to do that. Yeah, I can't believe I was able to do that either. If you're really interested in learning more, please come to our website. We have a whole bunch of free resources. We're all about free resources. We want people to learn and get knowledge and have fun doing it. So check out safe.com, check out the different resources that are available, including online courses, live chat with YouTube tutorials, and we have a whole community available as well.
Okay.
And on that note, I am all done. So
Okay.
Thank you much for tuning in. And if you didn't find it funny, I hope you found it useful.
Well, thanks, Kat. We really appreciate it. Yeah, so sorry if some of the audio was a little bit off, but I think it all came through very well, and your demonstration was fantastic. So we're going to go ahead and transition into Roger. And Roger, if you can unmute yourself, or I'll do it for you here, and we'll move into the next.
All right, no problem, thanks. And let me get my screen sharing here.
Okay.
Okay, share. All right, and let's see here. All right, can everybody see my screen and hear me okay?
I can see it. Take it away.
All right, thanks a lot. All right, as Brian mentioned, my name is Roger Comstock. I'm a compliance analyst with Atmos Energy here in Dallas, Texas. I've been using FME for quite a number of years, doing just what everybody was asking about, automating processes, scrubbing data, spatial analysis. What I'm going to be showing you today is one example of how we use FME to perform an analysis in response to an upcoming change in regulatory code. Okay, first a little bit about Atmos Energy. We're headquartered in Dallas, as I mentioned. We're the country's largest fully regulated natural gas-only distributor. We serve about 3 million customers in over 1,400 communities in 8 states, from the Blue Ridge Mountains in the east to the Rocky Mountains in the west. We're pretty proud of that. We also manage company-owned natural gas pipeline and storage assets, including one of the largest intrastate natural gas pipeline systems in Texas. In total, Atmos owns and operates over 75,000 miles of distribution and transmission pipeline. Of those 75,000 miles, about 6,000 of those miles are transmission pipelines within the state of Texas. And here's some information that serves as a segue into the FME presentation. It's getting some background on where we're coming from and where we're going. On the federal level, Atmos is regulated by the Pipeline and Hazardous Materials Safety Administration, or PHMSA, within the U.S. Department of Transportation. One of the regulations set forth by PHMSA requires pipeline operators to identify locations along their transmission pipelines where a release of natural gas could cause especially significant adverse consequences. These sections of pipelines are called high consequence areas, or HCAs. Operators are then required to devote additional efforts to the HCAs to ensure the integrity of the pipes and guarantee public safety. Locations of HCAs are determined by counting how many qualifying buildings or identified sites fall within a certain distance of the pipeline. For example, if there's 20 or more buildings intended for human occupancy, or at least one identified site within a pipeline's potential impact radius, then that section of pipeline is considered a high consequence area. I might note that there's 3 different flavors of identified sites. Outside areas or open structures, such as beaches or playgrounds or amphitheaters, or a single building where groups of people congregate on a regular basis, such as churches or office buildings or roller rinks, or a facility occupied by persons that are confined, have impaired mobility, or would be generally difficult to evacuate, such as hospitals, prisons, or schools. All right, and you might note on the slide also, for the identified sites, there's qualifiers on the number of people that have to be there and number of days per year. The number of days don't have to be consecutive in the year, so that's just one of the things I wanted to mention. Okay. Now, on the previous slide, I mentioned potential impact radius, or PIR for short, which is the area around a pipeline that is used for HCA determination. The PIR for a pipeline is actually a distance that is calculated using the diameter of the pipeline and the maximum pressure that the pipeline is allowed to operate at. It approximates the distance from a potential explosion at which death, injury, or significant property damage could occur. Therefore, the PIR for a 4-inch pipeline operating at 100 pounds, which is about 28 feet, is much smaller than a 23-inch pipeline operating at 600 pounds, which is about 508 feet. Pipeline operators must calculate the PIR for all points in their pipeline, then determine if the circle qualifies as an HCA based on the number of buildings and identified sites within the circle. Okay, and this is what's meant by evaluating each point along the pipeline, okay? Here's a circle on a pipeline. The radius of the circle is equal to the potential impact radius. As the circle slides down the pipeline, it is evaluated to determine if it interacts with buildings and/or identified sites. Okay, so the circle eventually begins to interact with an assisted care facility, which is an identified site. At this point, the circle satisfies the criteria of being an HCA. Okay, the circle continues sliding on down the pipeline, and as it passes the assisted care facility, it no longer qualifies for an HCA. It's pretty simple. Okay, so here's what the final HCA looks like. It begins with the first circle that interacts with identified site and continues until the circle no longer interacts with the site. The yellow indicates the pipeline, and the red buffer is the PIR around the pipeline. Okay, now we're getting to the part that's really pertinent to the presentation. A few years ago, PHMSA proposed a rule change that would establish moderate consequence areas, or MCAs. While similar to HCAs, the criteria for an MCA, as the name indicates, seeks to identify areas where potential injury and property damage could occur, but not to the extent of that in a high consequence area. So the proposal stated that an MCA would be defined as a section of pipeline that is not already an HCA and where its PIR interacts with 5 or more buildings, or an occupied site, which is defined as an outside gathering area, or the right-of-way for an interstate highway, freeway, expressway, or other principal arterial roadway that is 4 lanes or more. Okay. Note that there's no occupancy count or number of day qualifiers for buildings or outside gathering areas as there are for HCAs. Okay. Now, in preparation of the proposed rule change, we wanted to know approximately how much of our pipeline might be designated an MCA. So for determining the mileage of MCA pipe due to interaction with the highway right-of-ways, an FME workspace was developed using FME Desktop 2018. Okay. The FME workspace only required a few input data sets. The linearly referenced pipe center lines from Atmos's ArcSDE geodatabase, the existing HCA segments also from the ArcSDE geodatabase, and also we used the Texas Department of Transportation's roadway inventory database, which is a center lines of all the roadways in the state of Texas. And luckily, that data set included attributes which made it relatively simple for us to determine which roads would be considered for the analysis. Like I said, the freeways, highways, or principal arterial roads that are 4 lanes or more. Okay? So once I start the FME workspace and go through it, this is basically what it's doing. We start with the center lines from the TxDOT roadway geodatabase. We buffer the center lines by the right-of-way distance. We add the pipelines, and then we buffer the pipelines by the PIR. Now we start the process of elimination, okay? Because what's left over after we start eliminating stuff will be the MCAs, okay? So the first thing we do is we get rid of the PIRs that do not intersect the highway right-of-ways, okay? Then we eliminate the pipelines that aren't in the PIRs, and we create points along those pipelines. You can see the little inset, there's points. We just randomly chose 5 feet. Okay. Oh, let me go back. Sorry about that. Then we buffer each point to create circles around each point. So you can't tell very good on that slide, but those are actually one circle whose radius is equal to the PIR of all of the points that we put on the pipeline. Okay. Now we start eliminating the circles. We get rid of all the circles that don't actually intersect the highway right-of-ways. And then once we do that, we dissolve all the circles together, and that's our finished MCAs. Okay. Seems pretty straightforward, and it's really not that difficult. So what I'm going to do now is I'm going to open up ArcMap to show you our source data, and then FME to show the script that did all this. So get rid of that. And, oops. Okay, so here we have ArcMap, and you can tell the state of Texas. All the blue lines represent the TxDOT highway information, roadway information. So that's every road in the state of Texas. It's just center lines. It's not right-of-ways. The green pipelines, and then the red are actually the HCAs that we already have on the pipelines, the high consequence areas. Okay. So now I'm going to switch over to FME. So here's the workspace that does all this. And it looks complicated, but it's really broken up into little segments, just like you need to do with any kind of process. So what I'm going to do here is I'm going to zoom up on this area. And I think that's probably about a good zoom level. Hopefully everybody can see that okay. All right, so this is my first input. This is the TxDOT roadway center lines. And one of the cool things about this is I don't have to query every single line from that data set. What I can do is when I'm inputting the lines, you can actually go in and you can build a where clause. So this is the query for just pulling out the highways, freeways, expressways, and then the other principal arterial roads for the lanes are equal to or greater than 4. So right there, I'm saving a lot of time, so I'm not having to process all of the center lines from the roadway. All right. Also, I know Kat went over this, but I just wanted to show how many different readers there are available in FME. So go to more formats, and you can see this is even better than A to Z because it goes from 1 to A all the way to Z. So there's a ton of readers, different types of data that you can read, geospatial, flat formats, everything. So I just want to make a point of that. All right. So the first thing we do with the roadways is we keep only the attributes that we want. Okay, there's only select attributes that we needed to keep. And so I'm going to go through these pretty fast. Just the highway system, number of lanes, and the right-of-way width, and then the status, whether it was proposed or existing. I kept that in there. All right. The next thing we do is we actually reproject the TxDOT data to make sure it's in the same projection as our pipe. So everything will line up when we're doing this spatial analysis. And this is kind of cool because as I'm reading the data, I realize that there might be some highway center lines that don't have an attribute that says how wide the right-of-way actually is. So if that's the case, then I'm going to check to see if it has the number of lanes, and if it does, then I'll just approximate the right-of-way width. So here's a tester, and I'm checking to see is the right-of-way width numeric, is it a number, and is that number greater than 0? If it is, it's great, it just keeps on going through. If it's not, it goes to the failed port, and I'm checking to see, okay, does it have a number of lanes attribute? Is it a number? Yes. Is it greater than 0? Yes, that's cool. If it is, then what I'm doing is I'm creating the attribute for the right-of-way width. I'm just saying it's the number of lanes times 30. So if it's a 2-lane road, the right-of-way width will be 60 feet. It's just a way of approximating the right-of-way width on some missing data. So that's, it's kind of some data scrubbing that we were talking about there. All right. And then the last step I'm doing for the right-of-ways before I do the processing is I'm actually buffering the center lines by the right-of-way distance, because in our proposed code, we're looking at right-of-ways and not center lines. So that's a simple thing there. I'm just telling it the buffer distance is going to be this. And once we have that, then it'll flow on into the rest of the workspace. Now for the, save some time here, what I've done is I've actually pre-processed the roadways, and I've created a geodatabase of just the highway right-of-ways that we're going to be looking at. It'll save a little bit of time. And you'll notice here that this rider is grayed out. That's because I've disabled it. Now, if I wanted to reprocess my highways again, I could go over here to the reader. I could enable it, and it would process all the highways again. But since I've already pre-processed them, I'm just going to disable that. And just to make sure, I'm going to disable the rider that writes the highway right-of-ways to the geodatabase. Okay. And one thing you see here, just to be on the safe side also, I disabled the connectors that are flowing out of this that flows to the rest of the workspace. So you can disable readers, riders, and connectors. And so that's the highway right-of-ways. And this right here, this is the feature class I'm actually reading in from that output originally. So we're going to skip that right now. So now we're going to start looking at the pipelines that we have. Okay, so this is the input from our P-pipe. It's a UPDM feature class from the gas model that Esri provides. And then also we have the HCA center lines that are coming in. Okay. Let's see here. One of the things I wanted to point out is that you can create user parameters. So if you want to run the same workspace over and over and over, but maybe just change one parameter in the workspace, you can do that. And I'm going to go over here to my user parameters and look at these. I have created several user parameters. One of them right here, I can right click and go to edit definition. And basically this is asking the user, when I run this workspace, which one of our pipeline designations do you want to run this on? So D1710, okay? Another parameter is when I'm creating the points along our pipeline, how far do I want to put them? Well, my default value is 10, but this is a way that you can prompt the user to kind of customize the workspace every time you run it. So you don't have to go through there and change a bunch of stuff. All right, so let's continue on with the workflow here. And the first thing I'm doing is I'm renaming all the attributes that are coming from the HCA center lines, okay? And you can see here, I'll open this up, and I might want to zoom up on that. You can see all of the attribute names that are coming through, okay? But what I want to do is I want to bulk rename those. And the reason you might do that is to prevent collisions on down the workflow, like when you're comparing two different feature classes. So let me zoom up a little bit here, go back up to about 60. Let me just type that in. That looks good. All right. So when the bulk attributes come out, you can see that they all have a prefix on them now. So now it's the same attribute names except they're prefixed with conseg, just so I know they came from the consequence segment or the HCA segments. And like I said, you might do that to make sure that when you're comparing features on down the line, they don't collide with each other, the attribute names. All right. So on the HCAs, what I'm doing is I'm creating a very small buffer around the high consequence areas. And remember, one of the criteria for an MCA was it can't already be an HCA. So that's what I'm attempting to do here. I'm going to get rid of all the pipe that's already in an HCA. So I have my HCA buffers. I feed it into a line on area overlayer. And what that's going to do is it's going to break every pipeline segment at the boundary of every HCA. Okay. And it'll also tell me how many segments are intersecting. Well, let me open that up, sorry. It'll tell me how many segments are overlapping the HCA boundary. So right here, it's creating an attribute called overlaps. So if my pipeline overlaps 1 HCA, that attribute will be 1. If it's 2 or 3 or however many it overlaps, it'll tell me right there. So what I'm going to do now is I'm going to test. If the pipe overlaps equals 0, then that's telling me it's not in an HCA. So that's going to be pipe I want to continue processing. All right. Oh, this is interesting. I put a note on there to show you this. As you're going through and building your workspaces, you might kind of touched on this. You can add attributes or annotation to help you remember what you're doing on your workspace. This is just annotation I've attached this. And once you've attached it to a transformer, you can move the transformer and the annotation will move with you. Also, you might see these frames. These frames are called bookmarks. And it's the same type of deal. You can group your transformers together, and once you have them grouped together, you can move them around together. And another cool thing is these workspaces kind of get busy sometimes, so you can actually minimize that, and so it'll minimize that bookmark, so it'll kind of keep your workspace looking a little bit cleaner. If you need to come back and modify the transformers in this bookmark, you just open it back up, make your modifications, and move on. All right. So continuing on with the workspace here, the next thing we're going to do is we're going to calculate the PIR of each piece of pipe coming through. All right. Once again, I'm going to remove some attributes that aren't needed. I'm doing some more data checking here. I'm verifying that the diameter and pressure exists. Once again, it's very simple. Is the nominal diameter numeric? Is it greater than 1? And is the MAOP or the pressure, is it numeric and is it greater than 1? Okay, if it is, I keep on going. If it's not, I'm just dropping it out of the workspace right now. Now, this might be a case where you might be interested in knowing where those pipelines are that didn't have enough data. So there's a couple of things you could do. You could actually connect an inspector here. And what an inspector is, that once you finish running your workspace, it'll come up with a graphic view of everything that you've attached an inspector to. So this would show up and you could look at it, figure out which pipe it was, or you could actually add another writer. So you could write it out to a spreadsheet, a geodatabase, or whatever you wanted to get the list of pipelines that didn't have enough data. So I'm going to delete that. Right here is the attribute creator where I'm actually doing the calculation for the PIR. And you can see the PR, I'm creating the attribute, and it's equal to this. Now, it's pretty cool because you can open up the arithmetic editor, and you actually have access to all your feature attributes. You have access to any published parameters that you might have defined up front. So you can actually build your mathematical equations using pretty much a graphic user interface instead of having to type stuff. It's pretty neat. Okay, so once we have the PIR for the pipelines, once again, we're going to buffer the pipeline by the PIR. And I've actually added a tolerance in here in case our pipelines weren't exactly in the right location. I've added a tolerance, and it's defined as a user parameter over here. I think I put 10% as the default. So, you know, if our pipeline's not exactly in the right space, we'll buffer it by a little bit extra to make sure that we're catching all the buildings and identified sites that might contribute to it being an MCA. All right. All right, so the next thing we're going to do is we have, okay, so we have all the buffers. Let's see, and once again, the workflow is the PIR intersecting the highway right-of-way. It's just a simple spatial filter. And then if it is, it keeps on going. And I'm checking to see is the pipe segment within that PIR that intersects at the highway right-of-way. Of course, if it is, we just keep on going. This is just like the slides that I went through before. And then what I'm doing here is I built a custom transformer. I don't know if y'all can tell, but that's actually green. And a custom transformer, sometimes there'll be a transformer that FME provides that is okay, but it doesn't do exactly what you want, so you might have to build your own custom transformer. And this is one that I did, and it's actually right here. So the tab, this is all the transformers that make up that specialized transformer that I made. And all this is doing is, for every pipe segment that's coming through on the workspace, It's figuring out how many vertices it has, and then it's creating a point at the begin vertex, the end vertex, and then every however many feet I told it to do. So 5 feet is the user parameter I use. So like I said, for each pipeline that comes through, a point at the begin point, end point, and then whichever measure distance that I specified. Okay, so now I'm going to go back to my main workspace. Oh, and one thing I wanted to point out here, if you want to do any kind of looping, you have to use a custom transformer. This is actually testing to see if the next point is still within the measures, the begin measure and end measure of that line. If it is, it loops from this point back to this point. And then it'll just keep on processing and outputting the points until it runs out of line to process. All right. So once we have all that, we have the PICs, because we're buffering each point by the PIR, so it makes the PICs. And now I'm here, the simple part again is I'm just asking, does the PIC intersect the highway right-of-way? If it is, then it's going to come up here, and it's going to split off here. Now this is cool because anytime you split off an output into 2 different connectors, you're actually doubling the number of features that you have running through the workspace. And the reason I'm doing this, I'm splitting them out, is because we have MCAs and HCAs that might span 2 or more routes in our data. And so what I'm doing is I'm generating a unique number for each MCA that's comprised of 2 or more pieces of pipe or routes. And then I'm also doing them individually by the route names and then just marrying them back up with the name right here. So I'm just creating a unique ID basically. So that's it. And then, yep, concatenating the attributes from the MCA name, and we get the final output. So what I'm going to do is I'm going to attempt to run this real quick. I think it should go pretty fast. One thing to know that if you have user parameters, and this is version 2018 that I'm using. It looked like that Kat was using 2019. It might be a little bit different. But if you want to stop your work, not stop, but when you start your workspace, if you want it to prompt for the user parameters, make sure that this button is checked. And then when you run it, it actually comes up and asks the user for all of the parameters that you want to run. So I'm going to be running this on D1710. My distance between the PIR points is going to be 5 measures. In this case, it's feet. And then my tolerance percent for the PIR is going to be 10%. So let's run that. Oh, darn it. You know what? I made a mistake. Let me do this real quick before I mess up my real data. Okay. This right here was set up for my production environment. And so what I'm going to do here, and this is the actual feature class that you're writing the data to. So MCA from highway. So what I'm going to do is I'm just going to add demo right there. So it's going to write this out to a new feature class called demo. So you see how easy it was. If you wanted to create 2 or more feature classes and you have a template for one, just copy it, paste it, rename it, and that'll write a new feature class to your geodatabase. All right, so now let's go back here and I'll run it, same parameters, hit OK. And one of the cool things about FME, as you probably saw when Kat was running it, is that it keeps a count. It's making connections right now. It makes a count of how many features are running through. And once it gets going here, it's going to start reading in a second. You can actually zoom around and actually look at your workspace as you're running it also. Okay, so right here, it's starting to count 1. Well, it's going. Hopefully it'll speed up here a little bit. Oh, here we go. Let me zoom up so you can see that a little bit better. So you can see these numbers as it's processing. It's reading 49 features, 49, 6, 6. So it's going, and what it's probably doing is it's probably reading, yeah, it's reading all my highways right now. So it's up to, I don't know if you can tell, that's 39,000, 46,000. So I think that's all of the highways it's read in. Let's zoom over and down. And you can tell the numbers are still changing here. This is almost like watching paint dry or grass grow, I know, but.
Well, we're right at 1 o'clock, Roger.
Okay.
And fantastic presentation, both of you, and Kat and Roger. I want to we can let this run while we go through a couple quick things. Some people are going to start to jump out if they have a hard time. Patrick, are you unmute yourself, and did you have anything to say? I want to post the last slide of the presentation on your PowerPoint, Roger. And
Yep, no problem.
No, Brian, I didn't have anything else to add.
Oh, yeah, and one more thing. Remember, Area 51 is an extremely high consequence area, so don't go there, people.
Nice. All right. Well, we appreciate everybody sticking with us today. Little audio issues, but nothing too major. The video will be posted up to the YouTube channel here shortly, and we hope that you all can use this to integrate this FME into your daily workflow. So please let us know what you thought, and we will see you next month. And again, you all have a great rest of your day, Kat and Roger. Thank you so much, and appreciate it.
All right. Thanks.